A rhino manager is constantly struggling to deter poachers. The value of rhino horn is so great it can be very challenging. One approach is to devalue the horn, for example removing it, like you can see here. But notice that some of the horn is left. Much like trimming your fingernails, a small stub is left to avoid causing any harm. A poacher may still kill a rhino to gain this stub. Other methods to devalue rhino horn include dyes, poison, and GPS tracking. But like dehorning, the full value cannot be eliminated. So what we've got is a game theory problem with two players who each have two strategies. One player is the manager, who can choose to devalue or leave the horns intact. The other is the poacher, who can choose to behave selectively, and that is only invest time and effort into killing a rhino with a full horn, or to behave randomly, and that is to kill any rhino irrespective of the state of the horn. So a manager can choose to devalue R rhinos and leave the other portion intact. So that's R have been left intact, 1 minus R. R have been devalued, 1 minus R left intact. That's 100% of the rhinos. Otherwise, you've got S behave selectively, 1 minus S behave randomly. So it's S selectively, 1 minus S randomly, 100% of your poachers. Now, if all the poachers are behaving randomly, a rhino manager isn't going to waste money on devaluing them and is going to keep them intact. Whereas if they're all behaving selectively, it's worthwhile investing the money in devaluing, and the poacher's going to go somewhere else, and this manager has saved his or her rhinos. Alternatively, for the poacher, if all the rhinos have been left intact, then there isn't any point in trying to figure out whether they've got horns or not. You can just assume they have, and the poacher's going to behave randomly. But if they've all been devalued, then it will pay a poacher to behave selectively and go somewhere else and choose rhinos which have got a full horn somewhere else. So essentially you've got either the poacher wins, which is here, they've all been left intact, they're all behaving randomly, or the manager wins. They've all been devalued, the poachers are behaving selectively, and they've gone somewhere else. So let's look at which one of these two equilibriums the system's going to settle in. So if we look at the variables for the manager, we've got C, which is the cost to devalue all rhinos. Alpha is the density of the rhinos. And K is the cost to replace one killed rhino. Now the cost to devalue a portion of the rhinos is related to the density. If all the rhinos are lined up, then the cost to devalue the last one is going to be the same as the cost to devalue the first one. So you'll have a linear relationship. This is C. But in reality, the last few are more expensive to devalue because they'll be sparse and it takes more time and effort to try and find the last few. So in reality, the first few are cheap, the last few are expensive, and you get something more like that. And the more sparse they are, then the steeper this curve. So somewhere like Kruger National Park, the last few rhinos that you haven't dehorned would take a lot of effort to find, so they'd be the most expensive. Now let's look for the poacher. They've got H, which is the gain from a full horn. They've got gamma H, where gamma is less than 1. It's a gain from a partial horn. You've got F, which is the cost, and by cost I mean the time and risk to find a rhino. T, the cost, again we mean time and risk to kill a rhino. And then we've got D. This is the cost to discern whether it has a full horn, whether intact. So the costs here are to do with the time and the risk, and the gain is the monetary gain from the horn in relation to the poacher's salary, normal everyday salary. So it turns out, if we look at the what the expected payoff is to the manager first. So the key relationship is between K, the cost of one killed rhino, and C, the cost to devalue all the rhinos. That's the key relationship. So let's look at the two situations. One where the cost of one killed rhino is high in relation to the cost of devaluing, and one where it's low. And the expected payoff we represent like this. So if this is 100% have been devalued, 100% have been devalued, and this is 100% are selective. The expected payoff when the cost of one killed rhino is high, then we get something like this, and this is loss. And when we mean by loss, we mean wasted resources, and this is gain. And by gain, we mean that it was worthwhile devaluing. So when all the poachers are random, which is down here, you can only make a loss by devaluing any of them, which is what we said here. When all of them are being selective, then it is worthwhile devaluing them. And this here is where you break even. So here it's a high loss, here it's not much of a loss, and here it's a high gain, and here it's not much of a gain. Alternatively, if the cost of one killed rhino is quite low compared to the cost of devaluing all of them, get something more like this, and this is loss, and this is gain. So this is, you've got more chance for loss. Again, if all of the poachers are behaving randomly, you can only make a loss. If all of them are behaving selectively, then you've got a higher chance for gain, but still it's not worthwhile devaluing most of them, because the cost here is high, so you only really want to devalue it when the cost is cheap, when the cost is low down here, otherwise it's a waste of resources, and you may as well just incur the cost of a killed rhino instead. That's the expected payoff for the manager. And what about for the poacher? So the key relationship for the poacher is between the cost to find and kill a rhino in relation to the value of a partial horn. So when the cost is high, we'll look at that one when it's higher than the value of a partial horn, and when it's lower than the value of a partial horn. So we'll draw the same graph, the same axes before. This is 100% have been devalued, and 100% are selective. 100% have been devalued, and 100% are selective. So in this scenario, we get something like this. So this is saying that if all the horns have been devalued, then you're going to make a loss. The value of the partial horn here isn't that great, and you're only going to make a loss. If they've all been left intact, you can only make a gain. And this is a line where you're breaking even. But this is interesting. Look at the direction of this line. If you were a poacher and you didn't know what the value, how many have been devalued, you're still always going to choose. If you have to choose between one of these extremes, being random or being selective, you always have more chance of a gain by behaving randomly. There's just a greater chance of making a gain. If we look at the value of a partial horn is quite high in relation to the time and the risk associated with finding and killing a rhino, we get something like this. So we get a huge chance for gain because it's still worth it even though there's only a partial horn, because the partial horn has got a lot of value. And there's only a small chance for loss. And in fact, we can only really make a loss if nearly all the rhinos have been devalued. But we've seen here that it's not really worth devaluing the last few for the poacher, so for the manager. So the manager is unlikely to devalue close to 100%. And even so, you can only make a loss by behaving selectively. By behaving randomly, you cannot make a loss, you can only make a gain. So what we've shown is that a rational poacher is always going to choose to behave randomly, which means we're always going to settle in this equilibrium here, which is the poacher wins. Even if nearly all the rhino horns have been devalued, which isn't going to work out for the manager anyway, because that's just using too much of its resources to find these last few. They're better off incurring the cost of a killed rhino. Then even in that situation, it's still very difficult for the rhino poacher to make a loss. They would have to behave irrationally and behave selectively. So this is a difficult game for the rhino manager to win. And what we've really shown is that alternative measures need to be taken, because even if the time and risk are very high, say policies, say there was more policing, or say there was stricter, greater risk by associated with the time, it's still very difficult to convince a poacher to behave selectively. Thank you.